All right, let's talk aluminum rear axles. I guess it doesn't have to be aluminum. Mine's aluminum. Um, a new rule that was started in 2018 for Formula 500 in SCCA was to allow aluminum rear axles. Um, the rule specifically states that it has to be, I think, 7500 series aluminum, and I prove that your axle is a certain alloy. I guess you could just point to wherever you bought it from and hopefully the stewards believe you. But anyway, it allows for aluminum rear axles. So I decided I didn't like my old setup. My old setup was a steer rear axle. It was 1 3/8 inch diameter, which I'd never seen another car that had the same diameter, so I couldn't share parts with anybody, which kind of stinks, because if you have something bad happen and you don't have that spare, it's nice to have something that's a little bit more common to everybody else. So there was nothing keeping me tied to that setup. So I decided, why not? I'm going to switch over to this aluminum setup. I think it's more rigid for sure. The math says it's more rigid than the steel setup. And then the other big benefit, actually a huge benefit, is the steel setup, pretty much everything that slid onto the axle. I could buy the axle. I knew of one supplier that had the axle, and then everything that basically attached to the axle was custom built, which kind of stinks because it means that getting spares in short notice is almost impossible unless you have a builder that you know who's willing to put in time on a weekend and then FedEx you a part, I guess. So I wanted to try to find something that was all off-the-shelf parts that were readily accessible and available from multiple vendors, with the end goal being, can you come up with parts for a car that you can source off the shelf, and that way you can kind of publish your findings to everybody, and if they want to go that route, they could either go the same direction or at least go something similar to it. With the ultimate end goal, I should probably state, being an open source car where you can download plans that have everything for the frame, that have kind of a shopping list on where to buy parts, and hints and suggestions and recommendations on how to get everything set up. So to start that process, I have started trying to source parts as much as I can that fit off the shelf. Now, I have an existing frame. Obviously, I have a car. So some of this is my frame specific, and there are some parts of my frame that I would change and probably will change if I was starting from a blank canvas. So keep that in mind. But anyway, back to the axle. So aluminum axle. This axle is sourced from Speedway. It is one of their 52-inch. I can't remember exactly. I think it says their universal 52-inch axle. It's nice because it has the sections. There's basically 3 sections on the axle. There's the center section that is, I believe, 17 inches, and then from here out towards the end of the wheel, and from here out to the end of the wheel are the same on each side. It's the same measurement on each side. They are splined, and then there's a threaded connection on the end to kind of like lock everything together. What I learned in reading and studying about mini sprints, which is what this axle actually is intended for, those are the cars that are open wheel dirt track cars that have like the big steep wing on the back and a little wing up front, and some of them ride without wings. A lot of them are 600cc motorcycle engine powered. They can tune their engines and do so and make really a lot of power for the car. Same approximate weight as our asphalt cars. So this setup is intended for those cars, and I've adapted it to the F mod here, which is kind of nice because it can basically roughly take the same horsepower, and roughly the same forces are imparted on it. So this aluminum setup, come over here a little bit more, we'll look at the brake side here. So you can see I've got this wheel off. There's a hub that slides on there that is splined. So if you look at the hub on the wheel here, you can see, I don't know if you can see that or not, a little dark, but it's splined, and then it just bolts to a standard. This is a Kaiser wheel, but there are lots of different manufacturers that make a 10-inch rim, which is what is required by rule for our class, and that the hubs bolt into. And so, spline section, these are some individual spacers that I use. This is kind of nice because it allows me to very easily change the rear track width of the car, so the rear total width of the car. I can take a spacer out and put the wheel back on there and make the rear end narrower if I want to. So that's something I haven't really played with too much. We basically made it max width and ran it like that for most of the year last year. If we look at the upright assembly here, so this is the bird cage. I did have to design and make this to adapt to my specific car. So you can see it's got this chunky center section that's solid aluminum. It houses a bearing, and that bearing rides on, actually I'll grab that in a second. It houses a bearing, and that bearing is what supports the axle. And then it has these two outer plates, which obviously connect to everything. I had previously done new bird cages for my old axle setup, so I already knew where these points were, where I wanted my my forelinks to attach to, and my push rod to attach to. So I just went ahead and made new ones, just because I knew where everything would line up. Standard off-the-shelf Willwood caliper, again sourced from Speedway. It's one I've had in the car forever. That rear brake rotor, this crazy scallop thing with holes drilled all through it, that is sourced off the shelf. I believe that is from Hyper Racing. The attachment, the hub that it's attached to is splined onto the axle, so it just slides onto the axle. It is also sourced from either Speedway or Hyper. I can't remember which one. I think that's the Hyper one. And then these are just aluminum spacers that kind of space everything and keep everything in the right position. This whole setup I'll get to in a second. If we skip around down, the chain sprocket is kind of like a known sprocket. You know, that's a standard mounting pattern. I believe this one is 6 by 5 1/4. It is mounted to a hub that is also an off-the-shelf part. One is from Hyper, one's from Speedway. I bought one of each just to kind of test them. They've both been fine. So I would tell you, just source whichever one is cheaper, and they've been great. More aluminum spacers here. The other bird cage, obviously very similar to the one on the other side, except it doesn't have a brake mount. I just run one rear brake. And then you can see I left this rear wheel on, so you can see, you know, the hub is pushed tight to the aluminum. And if I pull the camera around here, there are some spacers on the inside, and then this big nut, center lock nut. And so on this side of the car, it's reverse thread, and it basically gets cinched down, and it pushes against all those spacers and everything, and that's what sets the position of all the different components on the rear axle. So the length of those aluminum spacers, which I'll go back through. So the length of these aluminum spacers on the inside, there's one here, there's one between, there's one on the outside here. Those are all very critical. So those have to be cut with some precision when you make those, to make sure that everything lines up where you want it to. Okay, going back to the rear axle, let's talk about this is my lateral location. So this was inspired by Jay Novak. So Jay, if you watch this, know that this is your fault. It's actually worked really, really well. So this, I don't know if you can see it, you can kind of see it. This is like a swing arm. It moves up and down. And then these two arms that connect to these bearing blocks have heim joints here. And you can picture that's what allows the axle to rotate. And because this can move up and down, it allows the axle to go into bump and rotate at the same time. So where these two lines meet is the rear roll center. So you can have a theoretical roll center point, because it's not physical, they're not physically attached to anything. You know, it's where these two meet, which is pretty close to, you know, the center bottom of that lower kind of tray that moves up and down and bump. The bearing that's inside these blocks is dual angular contact, meaning it's rated not only for a radial load. So if you were to look at, actually let me grab a bearing here. So this is the bearing that is inside my bird cages. It has a little rider that it sits on. You can see its spline on the inside. And then this piece just slides into, it's a pretty tight fit. That would slide or be pressed into the center of the bearing, which if I had more than one hand available, I could show you a little bit better. Let's see, give one more shot. I'm not gonna try with it. So that sits inside, the bearing rides on the outside. There's another bearing that is basically twice as big as this, that is inside these assemblies. This bearing is only made for a radial load. So a radial load would be a load that pushes through the bearing, right? These also are rated for an axial load, which means a load that is pushing that inner race and trying to push it, through the bearing, through the axis of the bearing. So these bearings are made to take that lateral load, that load that wants to slide the axle through it. That was actually a change I figured out pretty short term, or pretty quickly, once I had it first assembled, because I initially had just the radial load bearing in there, and then had to switch over to that dual angular contact that would take that axial load, because we were stressed those bearings pretty hard just in our first couple events. So learned that lesson pretty quick. Anyway, so these are custom made bearing housings, along with this bracket and the arm and everything. Like I said, if it were to be a different setup on the rear end, I would take probably what I've learned now and just change the dimensions of some things. I think I could make it more robust and give a better ride. And that'll probably happen as I continue to kind of plow forward slowly with this concept of a open source car. But anyway, that's the rear axle. Like I said, that specific axle is 1.75 inches in diameter, 27 spline. They have a 2-inch version. I think if I were to do it all over again, I would have put everything on the 2-inch version, just because I feel like there are more parts available for that size. And obviously 2 inches would be that much more stiff compared to the 1.75 inches. But anyway, that is about it. If you guys have any other questions on that setup, let me know, shoot me a message. I'll do what I can to answer it. Catch you all later. Have a good one.